Welcome to this demonstration of Schneider Electric's Asset Link solution, in which we will show how a user-defined function block in Control Expert can be integrated into Aveva System Platform by using Asset Link's feature to generate a custom pattern. Please bear in mind that this is a basic demonstration, not intended to replace any formal training. The user might also need to adapt the configuration shown to the actual project requirements. The software versions used to implement this demonstration are listed on this slide and are the most recent versions available at the time this video has been prepared. The integration process can be summarized as follows. First, the variables of the Modicon PLC application are exported to an XSY file. Asset Link will then scan this XSY file to create a pattern file. Once the pattern is saved, you can scan the XSY file again to create assets in Aveva System Platform for each instance of the user-defined function block in the PLC program. Lastly, any graphical templates in the Aveva System Platform Galaxy can be instantiated as needed in the InTouch OMI View app. We will start by working on a new PLC application, which will be for an M580 controller. In the project settings, we enable the data dictionary to communicate with the Modicon communication server, which gets data from unlocated variables in the PLC by means of the UMAS protocol, and then makes data available to Aveva System Platform via OPC UA protocol. To save time, I will import a section that already has the sample function block. As an input to this function block, system bit S6 will increment the counter once per second. Inside the function block, there's just a simple logic to update and reset a counter. It will also set a Boolean variable whenever the current value of the counter is a pair number. Now, for Asset Link to detect function blocks that match the variable names in the pattern files, we need to define a DDT type for our variables, which we can then use for a structure that will contain the variables exchanged with Aveva System Platform. When you create the structure name, consider it as having two parts. The first one, which is associated to an equipment name and will change with each instance of the function block, and the second part of the structure will remain fixed. In this example, the first part is the equipment name CTR, which will change for other instances as we add examples for pump 1, pump 2, etc. The second part is counter FB underscore ST, which must remain in the structure variables used for the other instances we will create. Following best practices, the instance name of the function block itself is the equipment name, followed by the name of the function block. This is a recommended best practice, and it's precisely what you will see applied in the Control Expert General Purpose Library, or GPL, as well as the Process Expert applications. Lastly, since we are using the data dictionary, please make sure that any variable exchange with Aveva System Platform has the HMI variable attribute enabled. Now we just need to build the application, and if there are no errors, we then export the variables to an XSY file. We connect to the simulator, which will start if it's the first time that you connect, and then we transfer the application to the simulator. Once this is done, you should be able to see that the program is running and the counter present value is increasing. Once the counter reaches the preset value defined at the input pin, the counter will reset. Now the Control Expert simulator will communicate with the Modicon communication server, which has already been configured to communicate with the local host for a device that I called M580. Also, the required credentials have already been set up for the MCS underscore connection group, with an update rate of communication with the PLC of 250 milliseconds. We are now ready to create the new Aveva System Platform Galaxy, starting with the default _empty Galaxy type. I selected this template because it will be a clean empty Galaxy, which will simplify showing the features highlighted in this demonstration. It is worth mentioning that the asset link is very often used with the General Purpose Library, or GPL, either as a standalone application or with EcoStruxure Process Expert. However, the example in this video is not based on the GPL, and once the Galaxy is created, we just need to connect to it. Since we will write to some variables from the operator interface, we need to enable the Galaxy security. In this way, the operator can log on when the operator screen is available. Once security is active, you will be asked to provide the username and password and then reconnect to the Galaxy. Now we proceed to create a minimal system starting with an instance of the Win platform. Then we add instances for the App Engine, an instance for the Area, an OPC client, and the View Engine. Lastly, a new derived template is created for the View app. Now, before we start creating an instance in the View app, we need to configure it. To save time in this video, I will import a screen profile that I have already created with the default settings of a 1920 by 1080 pixel resolution. And I will also import a simple layout configured for Aveva OMI. This layout contains a navigation pane that uses the navigation app, which will automatically display its content on the main pane because it has the autofill feature enabled. Right on top of the main pane, we have another type of navigation app, and at the very top, the title bar where we can log in to the operator interface. So the last thing to do is to configure the View app derived template by adding the screen profile we have already imported as well as the simple layout. Once this is done, we can create an instance of this template and we can proceed to arrange all of our instances in the deployment view of the Galaxy. First, drag and drop the App Engine, into which we will then place the Area and the OPC client instances. The View Engine is now moved onto the Win platform as well. Then we finish the process by moving the View app into the View Engine. We now have a few more things to configure. On the Win platform, we can enable the in-touch alarm provider. Then on the OPC client, set the server node to the local host as we will be using the Control Expert simulator. The server name that we will need will be oi.gateway.3. Lastly, we need to add a scan group, which will be simply SG1 with the default update interval of 250 milliseconds. Now we will be using Asset Link, which actually has an object that we must import into the Galaxy. As explained in the documentation for Asset Link in Chapter 3 for the workflow, after running the installation files for Asset Link, its template will be available in the default installation folder, which will be in the C drive, Program Data, Schneider Electric, EcoStruxure Control Expert Asset Link, and then the folder for the template and pattern schema. So we wait a few seconds for the object to import into the Galaxy. Once the Asset Link template is imported, we can configure the settings to connect to the communication driver and the PLC application XSY file. So we will click on the Configuration tab and we will set the protocol to OPC UA. We must add the same device name configured in the Modicon communication server, which I mentioned I have already called M580. Then we select the available DIO name and scan group. Now, the OI address reference is also explained in the user guide for Asset Link. Here we basically need to add the reference to the device group that we have for the Modicon communication server, which will be mcs_connection.device group followed by ./da.0. An example is also displayed at the bottom of the screen showing the addressing format. Lastly, we add the path for the folder that we would like to use to store the pattern files for the project. And the last thing we need to do is to add the XSY file that will be used to scan the patterns and also to scan the PLC application variables. You'll notice that when opening the XSY file, it already comes with its extension in uppercase. I suggest you change it to lowercase, as this is the format shown in the documentation. As a version 2.1 of Asset Link, you should not need to change the extension to lowercase, but I still recommend you do this change to lowercase as a best practice. Okay, for now we will save and close the template for Asset Link, as we still need to configure the template for the function block asset before creating the pattern file in Asset Link. Notice I just mentioned that in the Asset Link template, we added the name of a folder where we will place our pattern files. It so happens that we also need to copy 2 PLC connection files into this folder. They will be found in the same folder from which we imported the Asset Link template, and they will have the extension XSD. We just need to copy and paste these 2 files into our folder of choice for the patterns of the project. Now we are ready to create a template for the function block. To save some time, I have also prepared the graphics and I just need to import them into the Galaxy. It's a very simple screen to display the 4 variables that are going to be exchanged with the PLC. There's one text box with an analog display for the present value of the counter. Another box will be visible when the counter present value is a pair number. Then we have a user input animation, so the operator can write a value at which we want the counter to reset. And we also have a button to force the reset of the counter at any time. Okay, we're almost done with our initial configuration. We can now create a new derived template of the user-defined device. Now we will add attributes for each variable of our function block into this derived template, which will be used for our custom asset of our counter. Let's add the first item of the DDT structure used in Control Expert. For example, let's add pair, which is a Boolean variable. We also need to click on the IO reference button, and we have to follow a special format to create a placeholder address that Asset Link will complete once the pattern file is ready. We start by entering 2 dots followed by an exclamation mark. Asset Link will later complete the items separated by these dots with the DIO name, the scan group, and the device name that we have already configured in the asset link template. After this placeholder, we enter the name of the structure in the PLC application, followed by a dot, and the name of the DDT item, which is also the name of the attribute of the Aveva System Platform asset, in this example, pair. Now we also add reset, also a Boolean variable, and we proceed to enter its placeholder address as well. We now add two integers, one of which is PV, the present value of the counter with its I/O address, and the other variable is preset V. Lastly, we link this template to the graphics that we have already imported into our toolbox. This method allows us to easily change the graphic template and push any updates to the instances derived from this template. Let's now create an instance of the counter template, which we will name CTR, precisely the equipment name of the function block currently running in the PLC application. We now open again the template for the asset link object, and this time we go to the Patterns tab. Click on the Create Pattern button, and now you have the opportunity to enter the equipment name for the asset that we have created, which is CTR. After selecting Create Pattern, Asset Link generates a list of rules, which are used by the software to create an instance in the Galaxy with the parameters detected in the XSY file. The rules we see here match precisely with the 4 elements that we configured in the structure for the function block in Control Expert. We just need to select Save As, give a name to the pattern file, and close. Now the patterns appear in the list of patterns available for Asset Link. Click on the Generation tab, then select Force Browse, and select Browse Control Project. As expected, the CTR object was identified in the XSY file, and it matches with the pattern that we just created. Since we already had this asset in our Galaxy, the suggested action is to update the asset. Select the CTR object as a candidate, and then click on Generate Objects. As a result, the message at the bottom indicates that one asset was updated. Now let's save and close. We can now inspect the updated CTR asset. Check that each attribute has the complete I/O address, and we are now ready to move the asset into the area where it belongs. Right-click to deploy. We can now open the InTouch OMI Application Manager and launch the application. As you can see in the navigation pane, the only asset we have included so far is the CTR equipment, which is displayed in the main pane. We can now log in order to be able to set values on the variables, such as the preset value, or we can activate the reset button. Now, the whole point of everything we prepared is to use Asset Link to detect multiple instances of the function block in the PLC application. So let's add a few instances. I find it easier to start in the data editor and create copies of the structure or the variable that we're using. Then I can rename them as Pump 1 and Pump 2. As you can notice here, this is helpful to inherit the properties of the initial structure, including the activation of the HMI variable attribute. as well as any comments. Now let's copy-paste the CTR function block once, and I will also copy-paste from this new instance or new copy as well. I suggest to update the instance names of each function block with the correct equipment name, which is pump1 for the first copy and pump2 for the second instance. Lastly, I will correct the name of the variables connected to the input and output pins, which would be pump1 for the first copy on each one of the 4 variables we are exchanging with Aveva System Platform. Then we repeat the procedure for the second instance, used for our pump2 counter. Now we can build the application, and notice that all these changes have been done online, as we were always connected to the simulator. We can see that the 3 function blocks are operating as expected. The last thing to do is to export the variables, which we can do by overriding the same XSY file that we have already configured in the asset link object. So that was it for Control Expert. Back in Aveva System Platform, open the Asset Link template, and when available, click on the Generation tab and select Forced Browse. Now you will see there are 2 new candidates detected with a suggested action to create them as new assets in the Galaxy. Select both Pump1 and Pump2. Click on Generate Objects, and then we should see a success message at the bottom indicating that the 2 assets have been created. As expected, Pump1 and Pump2 are now in the unassigned host area. So we can drag both of these assets into our area, and we can deploy both of them. Once this is done, we should also deploy the View app, which has been automatically updated with the changes. And we can proceed to open the operator screen. Let's log in again. In this case, I'm using the administrator username already available by default in the Galaxy. And you will see that in our area, we now have 3 assets available. You can click on any one of them to update the main pane. You can also use the navigation tool at the top pane, and as before, we can change values from the operator interface. This completes the first part of our demonstration, but the important question now would be, how easy would it be to update our Aveva System Platform application if we change the function block in the PLC application?